Hello and welcome to accounting. Today we're going to work on exercise 14.1, which is determining the price for a bond. If you're in my intermediate accounting class, we're going to look at exercise 14.1 in your Spiceland Seep Nelson text. If you're not in my class, you can probably follow along because I have the information for the first part right here on our Excel screen. So as I said, we're going to try and value a bond with the market price of a bond. And there's two pieces to this. We have to find the present value of the principal payment. So at the end of 20 years for this bond, our maturity is 20 years. So at the end of 20 years, BB Corp will pay the investor $100 million. So you have to find the present value for that payment. And then we also have a stated interest rate. So 11% times 1 million will be paid semi-annually, or twice a year on June 30th and December 31st. So that interest stream, that interest payment, we have to find the present value of that annuity payment. And once we add those two together, that's what we should be willing to pay for the price of the bond. So we'll start with the principal payment. That one's a little bit easier. We know at the end of 20 years or 40 periods, we will receive $100 million. So put that $100 million in there. And what we want to do is we want to find the present value of this principal payment. So using our using our market rate of interest or our effective rate, we're going to go to the chart in the back of our text and we're going to find the present value factor for a single payment in the future at the market rate of interest. And we've been told in the problem that our market yield is 10% annually, so we can divide that 5% for the semi-annually. And this is for investments of similar risk. So this is the interest rate that we would expect to get on investments of similar risk to the BB Corp investment. So we'll go back to the back of your textbook to Table 2. This is Table 2, and it is labeled present value of $1, which stands for present value of a single payment. And our number of periods, we're going to use 40 because there's 40 interest payments. We're going to use that, and semi-annual interest will be 5%. So it's our effective or market rate of interest divided by 2. So and 20 years is our number of periods, but we're getting paid twice. So 40 periods in total. So when you're back in Table 2, where it says NI, you'll run your finger all the way down the page till you get to 40, and then you'll run your finger across until you get to the 5%. Again, you want to make sure that you're at the 5% because that's the market or effective rate of interest. The factor is 0.14205. And again, we got this out of our textbook, but you could calculate this using Excel for the present value of a single payment. The next thing we're going to do is the interest. We would receive interest twice a year. The interest would be based on, so calculate it here, interest is equal to the face value of the bond times the rate times time. So here we would say that $100 million times the stated rate of 11% times 6/12 for time, because you're paid twice a year, so 6 months out of 12 months. And we get the total payment of $5,500,000. That is what you would be paid every 6 months if you held all $100 million worth of the bonds. But what we want to do here is we want to calculate the effective rate of interest and then the present value. So we want to know, we're getting paid this $5,500,000 40 times. What is the present value of that annuity stream? So we would, again, use the market rate of interest. But this time we will go to Table 4. The reason we're using Table 4 is because the interest payment is an annuity stream. We're getting paid twice a year over time, so we need to go to Table 4, which is labeled present value of an ordinary annuity. So this is an annuity because we're being paid every year. More than one payment is an annuity. And again, we'll do the same thing. We'll go and find the NI in the table. We'll run our finger down the number of periods until we come to 40, because we'll be paid twice a year for 20 years. That's 40 periods. And then again, we're going to use the market rate of interest. So we'll go across the page until we get to that 5%, which is 17.15909. Let me just make sure that I'm in the right place on my book. Going down the 5% to 40, 17.15909. So we now have the factor for both the principal payment and the interest payment. The principal payment is very small because it's only being paid once. The interest payment looks much larger because it's being paid 40 times. So that's the difference with the factors. We'll now multiply the principal payment piece times the factor. And we'll do the same thing for the interest. We'll multiply the interest payment times the factor for the present value. And then we'll add those two numbers together. And we'll get 108,579,995. And that should be the most that we're willing to pay for the bond. We are using the market rate of interest here. So we want to say, okay, based on my perception of the interest for bonds of this risk, I would only be willing to pay at 108,579. Now this bond is priced at 109, so it's really priced too high. It's more expensive than we think it's worth. So what you would do for the next two problem, or the next two letter groupings in number one, is you would find the principal payment and find the present value, and the interest payments, and then times the present value, and calculate a price for the bond, and then you would compare the price that you calculated to the price that was stated in the bond. In this instance, I would not buy the bond because it is too expensive. And that is how you would proceed for exercise 14.1. If you have any questions, let me know, and have a great day.